this lesson, we are going to look at scale factors and three-dimensional shapes. If the scale factor of two similar solids is a to b, then the ratio of their surface areas is a squared to b squared. This is no different than in the previous lesson where we looked at just the ratio of areas. It still has the word area. Now we're just talking about surface area because it's a three-dimensional object. And the ratio of their volumes is a cubed to b cubed. So now when we're looking at the volume, which would also apply to mass or capacity, it's what would happen if you filled it. It's going to be a cubic value. If the scale factor of two similar solids is 3 to 4, determine the ratio of their surface areas. Now remember, in areas, we square the scale factor. So we get 9 to 16. So there's the ratio of the surface areas. You could write it as 9 over 16 as well. Ratio of the volumes. We are cubing each value. So we end up with 27 to 64. And you could write it as 27 over 64. So areas you square, volumes you cube. The ratio of the volumes of two similar solids is 8 to 125. Determine the scale factor. So to go from scale factor to volume, we cubed. So to go from volume to scale factor, we cube root. So we're going to cube root 8, and we're going to cube root 125. We get 2 to 5, or you could write it as 2 over 5. We want to now find the ratios of their surface area. If you're starting with volume and you want surface area, you do have to go back to scale factor and work off of that. So we found the scale factor in A, so we work off of that to find the surface area. Surface area is scale factor squared, so 4 to 25. Each pair of objects is similar. By what factor is the surface area of the larger object greater than the surface area of the smaller object? So what we want to do, we want to find how much larger the large object is, the areas of the large object. So first of all, if we have to find the scale factor of the larger to the smaller. So the scale factor would be 3 to 1.5. Now we want to find out the factor that the surface area would be larger. So we need to square our scale factor. So we're going to get 9 to 2.5, 2.25. So now, there is the ratio of our surface areas. How many times larger is the second or the larger object? So what we can do is we can go 9 divided by 2.25, and we get 4 times larger. We can repeat that same process for number 2. It doesn't matter whether we choose the 5 to 3 or the 15 to 9, because 15 over 9 reduces to 5 over 3. So the scale factor here of the larger to the smaller is 5 to 3. Square both values because we want to look at the surface area. 25 to 9. So now we can go 25 over 9 is approximately 2.8 times larger. Now in B, it says, by what factor is the volume of the larger object greater than the volume of the smaller object? So we're doing the same thing, but now we need to deal with volumes. So we go back. We have the scale factor, but with volume, we cube this. So 27 to 3.375. There's our ratio of the volumes. Divide those. And we get 8 times larger. So the volume is actually 8 times larger in that larger area. But the surface area was only 4 times larger. All right, so there is a difference. We're just covering the item in surface area, but we're filling it with volume. Look at the second one. Scale factor was 5 to 3. Cube each part. We have 125 to 27. Divide 125 by 27. And we get approximately 4.6 times larger. And again, the surface area was only 2.8 times larger. Brenda is a potter. She is creating 2 similar vases with their dimensions related by a scale factor of 3 to 4. The larger vase has a volume of 9,420 centimeters cubed. Determine the volume of the smaller vase. So we're dealing with volumes here. So the first thing we need to do is cube our scale factor. So we have 27 to 64. Now we can deal with proportions. Our ratio is 27 to 64. The larger vase has a volume of 9,420. So make sure you set the proportion up so that the smaller objects are in the same area of the proportion, so either both in the top or both in the bottom, and the larger are both in the same relative positions. So in this case, we're going the smaller vase over the larger vase. We want to determine the volume of the smaller vase. So now we cross multiply. 64x equals 254,340. Divide by 64. And you get 3,974.06 centimeters cubed. So there's your volume of your smaller vase. The smaller tank in the photograph has a capacity of 1,400 meters cubed, and the larger tank has a capacity of 4,725 meters cubed. During the refining process, both tanks are filled with oil from a pumping station at the same rate. So that's important. They're being filled at the same rate. How many times longer will it take to fill the larger tank than it will take to fill the smaller tank? So what we need to understand is if we're filling it, are we dealing with a linear dimension, an area, or a volume? Filling it deals with volume. So we have to compare the ratio of their volumes. What does capacity mean? Because capacity is what we were given, 1,400 meters cubed, 4,725 meters cubed. Capacity means volume. It's how much you can fill it. So we actually already are given the volumes of these tanks. So if we want to find how many times longer it's going to take, assuming they are filled at the same rate, you take your larger tank volume and divide it by your smaller tank volume. And you get it is approximately 3.375 times larger. Or I guess it would take times longer is what we're dealing with. Now we want to know how many times greater is the radius of the larger tank than the radius of the smaller tank. So what we have to ask ourselves here is, what does the radius involve? Is the radius a linear dimension, so we would just need scale factor? Is the radius part of an area, or is the radius part of a volume? Radius is just a linear dimension. So therefore, we are just looking for what is the scale factor, and then how many times greater is the radius of the larger tank. So we know the volumes. We know the volume values. To go from volume to scale factor, we have to cube root. So you can either cube root each of those individually and then divide the answers, or you can divide those two values right off the bat and find the cube root. So if we divide them right off the bat, we get 3.375. So now we can find the cube root of that value, which is 1.5. So that is how many times greater the radius is of the larger tank than the smaller tank. So scale factor represents a linear dimension. Surface area, you square the scale factor. Volume, you cube the scale factor.